So in this video, we're going to go in detail on the network oversight model. So if you are aware, in the last video, I went over some basic networking concepts such as DNS, DHCP, and NAT. So this is how networking is set up at your home, for example. So the thing is, I missed something when I showed this. So something very important, which I didn't see the need to show in the first video, is basically the address resolution protocol. So this is because this is involved in the layer two of networking, basically the data link layer. So basically, when I was mentioning of how the packets would leave your PC to find another PC, even in your local network or outside, like a server. So it just not just uses your IP address. There's another layer of addressing that's used in the whole IPv4 networking. So that's where we come into this OSI model. So primarily we're going to focus on layer three and layer two, because that's where you're going to mostly have configuration issues, and that's where you're going to configure firewalls and other networking aspects. So basically, these are already pretty much done. You just use it. So, but in the layer two and layer three, you generally need like configuration for your use case that's specific. To use case. So basically now, like I mentioned, this is layer three and this layer two. So what's the difference? So the network layer is where we deal with IP addresses, right? So we have this 32-bit address. So um, so I think I'll go a little bit more in detail about the IP address scheme. So as you're aware, can I add a text in this? As you're aware, right, the IP address is really like a number. If you notice, it has it's usually in the format of up to 3 digits, right? XXX, XXX, XXX. Let's put it that way. So there's four dots. You notice. So what does this mean usually? What does an IP address really mean, right? So when you see this, usually what it means is it's actually a 32-bit integer value, and each how do I say it? Each dot represents like 8 bytes. So in computer scheme, if you notice, usually the data is represented in bytes and not bits. So that's why we split each 8 bytes of data in by the dot. And this is very important why we split it by four dots, which I'll explain further, right? So the main reason is okay. So like I mentioned, so this is 8 bytes, so which means like this will have a max value, right? So if you notice, if you have 8 bytes, it's two to the power of eight, right? So something like 255 limit byte. You have some limit of the max value you can have, right? Which is, I believe, 255. So you can have up to 255, right? 8 bytes, which is basically setting all the ones, right? This is, let's say, your IP address. So the thing is, like, this can be any value, right? So I just give an example. It can be 192, anything. So why do we split it in four dots? So another very important aspect in networking is subnets. So the idea of subnets is really, the thing is, you don't want to really like in your machine, right? So I think I would like explain it further with the interface. So okay, let's say, so let's say you have this IP address, right? So let's say this means that you're just identifying one machine, and usually, like, if you want to specify more machines in an IP address, you call it a subnet, and you usually add a slash, and it's called net mask, and you specify the mask. So let's say you just want the machine itself, then you want the exact IP address, right? So that means you want up to the 32 bits, right? So you put slash 32. This means that your subnet is only this machine. So in your entire subnet of slash 32, it'll only, so let's say you configure a route or add a rule, let's say, to drop packets from this subnetwork. This would mean that it'll only drop packets from a machine with this IP address. But let's say I change it to like 24, right? Minus 8. That means I am actually telling it, okay, my subnetwork is up to this point, and then any machine from 1 to 255. So really what it's saying is it can have multiple machines. So you can have up to 255 machines really like start. So if I do, let me move this 255 because it's confusing, right? Let's put a standard address, something like 172.168.2. So usually when I do this, this is an exact address, like I mentioned, if it's 32, right? So let's put this 32. Now, if I have another address, which is like 172.168.2, usually when I say like 24, I don't say, I wouldn't put a number at the end, right? Because I don't care, because it could be any number at the end because I say 24. So I only care, this is my actual address up to this point in this scheme that I care about. And my since my subnet is 24, I don't care what the number is. What I'm saying is like in that network, I can have any machine, that that with an IP starting with this values and then ending with any value from 1 to 255. That's the max byte range. Right? So yeah, so as I mentioned, so basically, so why is it important? So let's say you add a route, you have some devices behind Ethernet or something, and you configure it you want to configure it in a subnet, right? One has 2.1, one has 2.2. Then you will say in that Ethernet interface, you will configure the subnet to 24. So you allow the Ethernet. So that means like in a computer, if it's trying to find a packet, let's say you address a packet to a device in that network with that IP, so it's going to look in its interfaces. It's going to say who has the subnet, right? And then it's going to forward that packet to that subnet, right? So this is we all talking about whatever's happening here now is still in the network layer. So yeah, so up to 255. So similarly, like if you go 16 minus another 16, really what you're saying is all devices starting with this I2 IP A16 bytes of I network and any IP address in this. So basically, if I say send a packet to 172.168 and any number after, it's going to send to that route or work you configure. So I'll go a little more detail to that, right? So now you understand that. So again, as usual, if you want to resolve further, so you say anything starting with 172, this is the subnet basically. So if you configure an interface, the packets are gonna go there. Similarly, if you want to like allow all network, this is usually like involved when you're adding the default route, which I'll sorry, not 80, so which I'll go in detail further. So why do we need really the subnets, right? Why do we care about this network segregation in this matter? So one main thing is let's go in your machine. Right? So if you have in your machine, you have a PC, and you have let's say I make a PC here. Remove this. Put text. PC. So in your PC, you will have multiple interfaces, right? So let's say you have Ethernet. The Ethernet, and then you have Wi-Fi. Right, I'll put it above. So if you notice, usually you get an address, right, and a subnet. But let's see the use case here. Let's assume your Wi-Fi is connected to the internet, and your Ethernet is connected to another PC, which has no access to the internet, right? So this is usually, if you look, I think you've before tried to get internet connectivity to a PC connected to another PC, right? Probably in your use, one of your work or use case situations. So here, so if you see like, so I have Ethernet connected to this PC2. So this PC2. So now since I have this Ethernet connected, Uh, the thing is now this PC2 cannot reach the outside world, or it can only reach through this PC, right? So, or let's forget about that. Let's say from this PC, you want to reach this PC, right? So, let's say you're going to configure your own network, right? So, I'm going to configure my my Ethernet interface in this PC to have an address, let's say 192.168.2.100. Okay. So if I configure my Ethernet interface in this address, and I'm going to give it a subnet, so I'm going to say 24 right here. So it'll have a subnet configured in the interface. So I think if you notice, if you see, you can. This is what I mean: subnet mask. If you do IP config in your Windows machine, you can see your interfaces, right? WLAN. This is your Wi-Fi. This is your Ethernet adapter. As you can see, my Ethernet as a, this is the Hyper-V, so my Ethernet's not connected right now, so my Wi-Fi is a IP address and a mask. So as you can see, the mask of this Wi-Fi adapter is given to be 255, 255, 255, and 0, right? So I'll go into that in more detail. Um, so yeah, so as I mentioned, so let's say you put another IP address here. So this is going to be 101. Like it's because you can't have the same address, right? Because it has to be a different address each any interface in your machine. So now your WLAN is going to have its own network and subnet, right? Uh, let's say something like 2.25, something the router gives you, and there's a subnet. And the thing is now, so let's say you want to ping this. So usually, like, okay, yeah. So I wouldn't put it. So let's change. We wouldn't usually when you're configuring something like this, you wouldn't put the same subnet. So we'll put this in 172, right? And we'll put this in 172, or you can change even the 168. Doesn't matter. So basically, it shouldn't match up to the subnet part. So I'll tell you why. Basically, you understand why now. So if I try to ping or I want to SSH into this machine, I use usually this address, right? So I'm going to use this address 172.168.2.100. So when I use this address from this PC, it's going to look up its interfaces. Basically, look up its routing table, and it'll see. First, it'll look up its interfaces, and then look up its routing table. So in its interfaces, so like I mentioned, all the interfaces have the subnets configured, right? So when you do this ping, it's gonna look up Wi-Fi. It's gonna be like, okay, Wi-Fi does not have 192, so I'm not gonna use the Wi-Fi interface. Okay, but I'm gonna look at the Ethernet. It says, oh, I can use 172.168.2. Oh, I can use any machine, resolving at the end. So I'm gonna send this packet here because I believe any any machine in that sub network, like I mentioned, starting with 172.168.2 up to 255.0 to 255 ending is what this means is basically like all the machines you can find beyond this interface. So now when you send that ping or packet, it's going to go through this interface, find that you got through this Ethernet and find the host and the machine, right? So now there's another thing. So now how does, okay, let's say, so you see it's your Wi-Fi is configured in this IP address, right? So let's say how do you go to Google then? So in this case, when you're trying to reach google.com, so let's say google.com, right? So how are you gonna go? Because now it's gonna come to the Wi-Fi. It's gonna be like, oh, Wi-Fi, Google, because google.com is gonna be an external public IP, which is gonna be something like 182.643. I'm sort of sorry, one four, so one something 123, 123. Let's say 134. This is gonna be some weird IP like that. Uh, So if it's going to be an IP address like that, so how is it going to find? There's no interface configured with the subnet, right? Because it's starting at 192 here, for instance, or 172. So usually what you have is a default route. You will have a default route configured. This is where routing table comes into the place. So you can configure many routes usually, like for subnets for routing based on like conditions. So let's say, so in this case, I'm going to put a default route in this case, right? So default route in the routing table is the first route. It's the first rule is going to look up. So default, actually, sorry, the last rule. It can't match any other rule. That's the rule it's going to use. So in this default route, I'm going to say, okay, use Wi-Fi interface, right? I'm going to give the IP also. There's a command to add the default route. I can show that in more detail in following videos. So when I add this default route, so what's going to happen is when you're trying to reach a public IP, it's gonna check the interfaces, of course, which don't match. So it's gonna use the default route at the end. So it's gonna resolve, say, okay, I'm gonna use the Wi-Fi interface for this packet because I don't know, otherwise which interface to use. So it's gonna go out and you're gonna get the response. Similarly, now from this PC, let's say you wanna access the internet, right? So you're gonna add a default route through Ethernet, usually, which will again. So if you wanna access a packet through that's external, and it's gonna go use this route and go through the Ethernet, and it's going to go through the Wi-Fi again because it's gonna look for a route here again. It's gonna look at the default route, and it'll go out and come back. So yeah, so that's basically how you get access. So now, how similarly how PC2 can reach PC1 if you wanna ping. So you're gonna ping the 172 168.2.101 address. So now you're gonna say, okay, when I ping this address, it's gonna look up the interface as an Ethernet interface in that subnet. So it's gonna send the packet to this PC, basically because it's going to send to the Ethernet. So any device connected to the Ethernet, every device connected to the Ethernet will and should receive back, right? But usually it's one connection unless you have a router or a switch. So yeah, so that's detailed about IP address scheme, and so this is just in your local, scheming, right? So how to get connected? There's just one general use case. There's more very important reason why we have this mainly four way of splitting, because there's something called the CIDR or I forgot the full form of it. So basically, that's how they decide. Which region of the world literally your packet goes, right? So let's say your router, reaching 182. So 182 is actually reserved to a region of the world. That's why I meant, like, how 192 is usually reserved for your home network because nobody in the world uses it in the public domain. Similarly, like these network, these first especially these first three, they're reserved for like regions. I don't know, I'm not sure exactly, but like continents and countries. So that's how it finds, like, when you send your packet to 182, so it goes to your ISP, and your ISP knows, okay, 182 is in is north, or let's say North America region, and then 123 is it'll resolve even more the region more. That's how basically they know your location, right? Your rough location. How do they know your location based on your IP address? It's not GPS. It does not have any, not tracking services. It's just because of your public IP provided by your ISP. So if your public IP, if you're able to spoof it, change it, then you can make your location look like somewhere else. That's how you mask your location. Uh, hide your location basically. So yeah, that's about IP addresses. So I think I'm gonna stop there for now. I'm gonna continue in a follow-up video with the network new OSI. I'm gonna go with this in parts. So see you in the next video.